Hello everyone, how are you all? Oh, fine. So, as you all know, we have successfully completed one topic till yesterday's video. That is, we have completed sets. So, from today onwards, I'm going to teach you a new topic. The topic name is called statements. Before going to that, guys, please subscribe our channel and hit the bell icon, and please like, share this video. Okay, so let's start the topic. So the topic name is called statements, right? So uh, statement, actually a statement is a sentence which is either true or false but not both. So mathematically, if I can define you what is the exact meaning of the statement, so statement is nothing but a sentence which is either true or false but not both. Okay, so let me have a example for this. Sun rises in the east. Let me take a couple of examples here. 2 plus 2 is equal to 5, and one more, he is good boy. He is good boy. Okay, he is a good boy, right? Now here, if you can see, sun rises in the east. Okay, and 2 plus 2 is equal to 5, and he is a good boy. These are the three sentences I have taken. I'm not saying these are the statements. Okay, before going to come to one point, I'm considering these are the sentences. Okay, so now in the first sentence, sun rises in the east, is it a true or false? Tell me. It is a true statement, right? It's a true statement. So, and coming to the next one, 2 plus 2 is equal to 5 is, it's a false, because we all know that 2 plus 2 is equal to 4 only, right? Next, coming to this third one, he is a good boy. Who he is, we don't have any clarity, right? So he is a good boy means, when we don't have the clarity, how can we say that it is a true or false? So that is what, as I said to you, the definition of the statement, a statement is a sentence. A statement is a sentence, but it should be either true or false, but not both. It cannot be both. Okay, it cannot be a both. So this is not a statement. These two are statements, because they have the either of the truth values, so that is either true or false. Okay, so that is called a statement. Clear? So the truthness or falsity, okay, the truthness or falsity of a statement is called its truth value. The truthness of a statement is denoted by the letter T, and the falseness, that is its falsity, will be denoted by the letter F. Okay, so we use lowercase letters P, Q, R, like P, Q, R, so on, to denote a statements. Like for example, some P is a statement in which 3 is equal to 4 is equal to 12. 3 into 4 is equal to 12. So let me use a dark marker. 3 into 4 is equal to 12. So its truth value is true. So it's in a statement, right? Let's suppose some Q statements. All natural numbers are positive. So all natural numbers are positive. So it is also a true statement, right? So let's suppose take one more statement, like R. Okay, she is talented. So what is the truth value of this? So this sentence, we cannot say this as a statement. This is a simple sentence. We cannot say this as a statement, because who is she, we don't have any clarity on this, right? So a statement cannot be either true or false. Okay, it should be either true or false. It cannot be a both, or there should be some clarity. Okay, like this statement, like this sentences cannot be considered as a statements. Clear? So I hope so now you got the clarity. So what is actually the statement? So a statement is a sentence which is either true or false, but not both. Clear? Now here, as you have in a sentence you have some connectives like and, but. You are having connectives, right? So in between two or more sentences you have some connectives, like that in statements also we have the connectives. What is actually use of connectives? It will combine, right? So when you are writing Ramu and Sita are writing their homework, so and is one connective, okay, like that. Okay, so many statements are the combination of simple statements with some connecting words. These words are called connectives. Okay, like you have in your English language you will be having different connectives, like as I said to you, and, but. Okay, like that here also in mathematics in these statements we have different connectives. The statements that are composed of other simple statements with connectives are called compound statements. There you said compound sentences, here we are going to say compound statements. Compound statement means what? The statements that are composed of other simple statements with connectives are called compound statements. Okay, let me have one statement. Let us suppose p is equal to 2 into 3 is equal to 6, and q is a statement where 5 plus 4 is equal to 7. Leave it about the truthness of this. Okay, so we can form a number of compound statements by using these two. Okay, some of them, if I can say, if I wanted to connect a p and q with the connective and, then I will write it as a 2 into 3 is equal to 6 and 5 plus 4 is equal to 7. If I wanted to connect with r, then 2 into 3 is equal to 6 or 5 plus 4 is equal to 7. I am again repeating, don't concentrate on the truthness of the statements. Okay, we will discuss that deep later, but initially how you are going to connect, like 2 into 3 is equal to 6 and 5 plus 4 is equal to 7. That's it. Okay, simple. You are supposed to show how you are going to connect with that particular connective. Okay, so p and q, p r q, like same, 2 into 3 is equal to 6 or 5 plus 4 is equal to 7, like that. You can also take if 2 into 3 is equal to 6, then 5 plus 4 is equal to 7. Don't go deeper. Okay, just if it's like if p then q, that's it. Okay, I'm again and again, don't go as per the its truthness. Okay, I'll explain you later on. Okay, we have that topic also, we have that subtopic also. So here first we need to understand how the statements are connected by some connectives. So these are the connectives, different types of connectives. Okay, so here comes there are some basic connectives. Okay, let me start that connectives. What are the different connectives in the statements? Right, the first one. Okay, first one is negation. Negation is the first statement. Okay, I mean first connective in the statement. So simple, negation means nothing but it's negative, as you have in your English. Okay, for understanding purpose I am just comparing with the language. Okay, don't be taken in a negative sense. So negation means nothing but it will give a negative sense, like Ramu is a good boy. So what is its negative sentence? Ramu is not a good boy. Okay, Ramu is not a good boy, that's it. Okay, obviously Ramu is a bad boy. Okay, but when you are going to use that particular connective, you are supposed to show that it's like not a good boy, not is a particular connective, that negative connective, right? Like that only, if I take some p as a statement, then its negation can be formed by writing the word not before p, and it will be read as a not p. Simple. So if p is a statement, then its negation will be not p. Okay, so let me have it's a truth table. If p is a statement, then its negation will be denoted with the negation p. Okay, so how many truth value will be having by a single statement? Either it will be a true or false. So whenever you will be having a true, okay, for a statement, whenever you will be having a truth value as a true, then its negation will be having a false, and if it is having a false, then its negation will be having a true. Okay, like that only. If for example P is a statement that 3 is a prime, let us suppose P is a statement we have that P is a prime, then what will be its negation? Simply negation P that 3 is not a prime. So we have just included that negative connective not. Okay, so negation means it will be having the negative connective not. So if P is a statement, then its negation will be not P, and its symbolic form is this, and it is a truth table of negation. Clear? So let's go to the next connective. So the next connective is disjunction. Disjunction. Okay, the next connective is a disjunction. So here disjunction, its symbol will be, first of all let me tell you what is the symbol of disjunction. This, it's like a cap. Okay, so it will be read as or. Okay, so disjunction of two statements is false when both the statements are false. Let me have its a truth table so that you will be get more clarity. P Q, PRQ or QRP. QRP. Okay, so when we will be having the two statements, then the truthness of the two statements will be either both statements will be true, or one of them will be true and another one will be false, and one of them will be false, then other will be true, or else both the statements will be false. So normally we will be keep it in mind like a TTTF FTFF. Okay, whenever we will be having two statements. Now what will be its PRQ? Okay, yeah, sorry, I have done a small mistake. The symbol will be like this. Okay, so reverse of cap, like you can keep it in mind as a V symbol. So this is R symbol. Okay, now what will be the result of PRQ and QRP? Okay, as I said to you, disjunction of two statements is false when both the statements are false. So when we have both the statements are false, so this is the only case. Okay, this is the only case. Okay, so this is the only case where we have both the statements are false. So disjunction of two statements will be false only both the statements are false. So here only you will be getting false. Then what about the remaining? In remaining places you will be getting a true only. Same in QRP also. Q and P, from this to this, here also the same position, you will be having a false and the remaining will be true. So in these two positions only you got false. Have you got my point? So the disjunction symbol will be or, it's nothing but a V symbol. Okay, so the disjunction of the two statements will be false when both the statements are false. Okay, and whenever we will be having a two statements, we will be having its truth values as TT, TF, FT, FF. Okay, keep it in mind. Clear? So whenever you are going to write a disjunction, okay, so if both the statements are false, then the total compound statement, its compound statement formed by those two statements. So if both the statements are false, then the total compound result will be false. Okay, let me give you one example. Let us suppose P 9 is a perfect square. 9 is a perfect square. Q, what is Q? 7 is odd. So I have taken two statements, 9 is a perfect square and 7 is odd. Okay, then what will be PRQ? PRQ will be 9 is perfect square you are having or, so or 7 is odd. Okay, 9 is perfect square is what is its truth value? It's a true only, right? 9 is a perfect square, and 7 is odd, it's also true, it's also true. So what is the truthness of a PRQ? True. Whenever you will be having both false, then only it will be false, right? Okay, so that is called the disjunction. Now next, conjunction. So conjunction, this is little bit it will like look like an opposite of disjunction. Why? Because first of all, what is the symbol of conjunction? Conjunction symbol will be like this. So reverse of V, or you can keep it in mind as a cap. So it will be read as symbol and. For disjunction we have a V, that is R, and here a reverse of V, so it will be a read as a R and. Okay, so conjunction of two statements will be true when both the statements are true. Okay, let me demonstrate with the help of truth table. As I said to you, TT, TF, FT, FF. So let me repeat again. Conjunction of two statements will be true only both the statements are true. So this is the only case. There only you will be get true. In the remaining you will be get false, because both the statements are not true in any case. See, so the remaining cases will be false. Here also Q and P also, in Q and P also the remaining cases will be false. So this is the only condition, this is the only condition where you are getting both the statements are true. Then only whole compound result, I mean the truthness of whole compound will be true. So both the statements should be true. Okay, so like if I can say 2 is an even and 2 is a prime, 2 is an even and 2 is a prime. So what will be its compound statement which is connected with the connective conjunction? It will be 2 is even and prime. 2 is an even and prime means obviously 2 is even is true, 2 is a prime is also a true. So obviously 2 is even and prime, so true will be true only. So obviously 2 is even and prime, it's also correct. So by after connecting statements also you can check. Okay, so it will be get true only. Clear? So let's go to the next one, conditional. So conditional, its other name is implication. Okay, so conditional is also known as an implication. So its symbol is implies. Okay, normally we will use this implies, right? So read as it's only if only. Okay, like let me demonstrate you with the help of a truth table. P Q, P implies Q and Q implies P. Keep it in mind, whenever you will be having an implies, I mean implication statements or conditional statements, a true statement cannot imply a false statement. This is the only logic. A true statement cannot imply a false statement. Let me have TT, TF, EFT, FF. Okay, a true statement cannot imply a false statement. In P implies Q, P is a first statement, Q is a second statement, right? In Q implies P, Q is a first statement and P is a second statement, right? Now as per P implies Q, you need to check where you have P2 and Q as F. So in which condition? In second case only, in second case only. So here only you will get false, and the remaining, what about remaining? It will be true only. Now what about Q implies P? Q implies P also. Q is a first statement and P is a second statement, right? So Q is a true and P is a false. What is that type of condition? From this to this. So true and false means this third case, true implies false. There only will get false. Then what about the remaining? Remaining will be true only. Remaining will be true only. Okay, so a true statement cannot imply a false statement. So a compound statement will be a false only when first statement is true and the second statement is false. First statement is true and the second statement is false, then only a compound statement which is connected by this conditional connective will be the result, the truthness of that resulted statement will be a false. Clear? Okay. So that is what. Let's suppose P is 4 into 5 equal to 20 and Q is 4 plus 5 is equal to 10. So 4 into 5 is equal to 20 is a true, right? Is it true? And 4 into 5 is equal to 20 is a true. And what I told you, the second statement, 4 plus 5 is equal to some 10. It's not true, it's a false. So it is combined with the conditional. So if 4 into 5 is equal to 20, then 4 plus 5 is equal to 10. So true implies false statement. So total result will be, total compound statement result will be false, because you are having first statement truth value is true and the second statement truth value as false. So a true statement cannot implies a false statement. So the total value will become, total compound statement truthness value will become false. Okay, so that is called a conditional. Let's go to the next one, bi-conditional. So the next one, bi-conditional or bi-implication. So we'll be having the symbol this. Let me have more clarity. With more clarity. So this is called. So we can also, in a simple, we can also say that it has an double implies. Okay, so double implies. Now, so with this connective, so it will be read as a if and only if. Okay, so normally this connective symbol will be read as a if and only if. So let me draw first its truth value table P Q, P double implies Q and Q double implies P. So it's a Q, right? So TT, TF, FT, FF. Okay. So what it is saying that bi-conditional, when both the statements are either true or false, both the statements are either true or false, then only the truth value of the compound statement using bi-conditional will be true. Otherwise it will be false. So where you are having in a P double implies Q means where you are having both the statements are true or false. So this is one condition where you are having both the statements are true, and this is the another condition where you are having both the statements are false. So there only you will be having a true. Then what about the remaining? Remaining will be false only. Remaining will be false only. Here also Q implies P also, Q double implies P also. Only in these cases only will be having true, the remaining will be false. You can also a small logic for this, as you have learned in your basic classes, plus into plus plus, plus into minus minus, minus into plus minus, minus into minus plus. So you can consider true as a plus and false as a minus. So you can apply this rule. Okay, simple. If both the statements are true or both the statements are false, then the result of the compound statement will be a what? True. The result of the compound statement will be a true. Okay. Yeah. So this is what today's class. So I am going to give you the exercise problems for today's class. Okay, so just give me one moment. These are the topics I have covered so far in this video. So I hope so it is clear to everyone, and I would suggest you to once again go through the whole video so that you will be getting more clarity how the truth tables of particular connectives like negation, conjunction, disjunction, conditional and bi-conditional have been formed, because based on this you will be having exercise problems today I am going to give you. Okay, kindly note that. So first of all, for these four you are supposed to write that the symbolical form as like first it is given x is even or x is odd, right? So x is even, you are supposed to consider one statement like a P, R, and x is odd, x is odd, you are supposed to keep Q. So simply x is even or x is odd will be P or R symbol, as I already told you. So P or Q, like that. Okay, second one also P and Q. Third one, if p, because x is not an odd, will be not odd, that means if negation p, I mean, so negative of p, right, negation p, as I already told with you. So if x is negation, if negation p, then q. So x is even if and only if so already I have already shared with you all these things, so you can just try it. Okay, you are supposed to write the symbolical form. And next problem is, so these are the three problems. Okay, so negation p and negation q, you are supposed to write the truth tables. Okay, for these truth tables, I want you all to write the truth tables, construct a truth table for these all the three. I'm sorry. So negation p and negation q, and then p and negation q implies q. Consider this as a first statement and this as second. Okay, so negation of negation p or q. Okay, first you will find it out this, and then you will apply negation. Okay, like that you are supposed to do. You try it, as you know, in case you don't get any result. Definitely in the next video I'm going to share you the solution. It's not a problem. Okay, and then I'll go to the next one in the next video. Okay, so as of now, today I'm going to wind it up. So thanks for your support. Kindly subscribe our channel and hit the bell icon, and like, share the video as you can do. Thank you. Have a great day. Bye bye.